We will start our discussion about test-driven development by going back to a software life cycle that we examined a little bit ago, which is the waterfall life cycle. And if you remember, that was a fairly rigid process in which we were preparing documents and we were not starting any phase before the previous one was finished. And once a phase was finished, we were rarely going back to it. So today we're going to examine how it is possible to go from such a rigid process to an agile one, in which we can better deal with changes. So remember what we saw in the first lesson when Barry Beam stated that the cost of change grows exponentially with time. So if we imagine to have time over here on the x-axis and cost on the y-axis, you can see that the cost will go up more or less this way. And what that means is that finding a problem while collecting requirements will cost you much less than finding a problem in the analysis phase, which in turn will cost you less than finding a problem during design, and so on for the subsequent phases. So if this is the case and cost is really growing this fast as we proceed in our process, what should we do? The key thing is to discover errors early, before they become expensive, which in turn means doing a lot of upfront planning. And because models are cheaper to modify than code, we're willing to make large investments in upfront analysis and design models. And only after we have built and checked these models, we're going to go ahead and build the code. In other words, we're following a waterfall mentality. However, something definitely changed in the last 30 years. For example, 30 years ago, we needed to walk down a hall, submit a deck of cards to an operator, and wait a day for our program to run and produce some results. Today, we can leverage the computational power of the cloud. Computers used to be very slow and very expensive. Today, computers are 1,000 times faster and 1,000 times cheaper than what they used to be. In particular, if you think about the compile and test cycle, that has gone from days to seconds. Now we can change our code, compile it, run it our tests, all in a matter of instants, something that was unthinkable before. Finally, developers in the past had to do a lot of tasks manually, in a very time-consuming way, and often in a very painful way. Today, on the contrary, we can automate a lot of these tasks. We have high-level programming languages, version control systems, smart IDEs, basically a whole set of tools that can help developers, and they can make them more efficient. In general, what that means is it's easy to change, much easier than what it was before. So maybe if we take all that into account, the cost of change can be flat. So if we go back to our diagram, the one in which we show the cost with respect to the project time, maybe instead of having this kind of curve, we might have a different kind of curve. Maybe the curve is more like this one. So maybe we can make all of this happen as long as we use tools, practices, and principles in the right way. And we're going to see what that means.